NENOMATICA, where mathematics meets YouTube excellence. Exponential equations. Welcome to our lesson on solving exponential equations. In this video, we'll solve a challenging equation step by step using properties of exponents. Let's look at our example. We need to solve the equation 3 to the power of x times 8 over 3 to the power of x times 9 over 64 to the power of 2x minus 1 equals 9 over 8. Let's first rearrange our equation to work with the exponents more effectively. We'll rewrite the term 9 over 64 to the power of 2x minus 1 as 9 over 64 to the power of 2x times 9 over 64 to the power of negative 1. Now, we'll simplify the negative exponent. Remember that a to the power of negative 1 equals 1 over a. So, 9 over 64 to the power of negative 1 equals 64 over 9. Remember this important property of exponents. When we have a negative exponent like a to the power of negative n, it equals 1 over a to the power of n. Let's continue with our solution. We'll multiply both sides of the equation by 9 over 64 to simplify further. Let's look at what we're working with. We need to combine these exponent terms more effectively. Notice that we can rewrite the second term. 3 to the x times 8 over 3 to the x can be rewritten as 3 times 8 over 3, all raised to the power of x. Now we can simplify inside the parentheses. 3 times 8 over 3 equals 8. And 9 squared over 64 squared equals 9 squared over 64 times 64, which is 9 squared over 4096, or 81 over 4096. Let's continue our simplification. We have 8 times 9 squared, which is 8 times 81, giving us 648. And 64 times 64 equals 4096. This gives us 648 over 4096, all to the power of x. Let's simplify both sides further. 9 squared equals 81, and 64 times 8 equals 512. So we have 81 over 512, all to the power of x, equals 81 over 512 to the power of 1. When the bases are equal on both sides, the exponents must also be equal. Therefore, x equals 1. This is our solution. Let's look at our example. We need to solve the equation 0.5 raised to the power of x minus 4, multiplied by 1 over 0.125 raised to the power of 4 minus x equals 0.25 squared. First, let's simplify this fraction. 1 over 0.125 equals 8. So our equation becomes 0.5 raised to the power of x minus 4, multiplied by 0.125 raised to the power of x minus 4 equals 0.5 to the power of 4. Now, let's express 0.125 in terms of 0.5. 0.125 equals 0.5 cubed. So we replace 0.125 with 0.5 cubed. Applying the power of a power rule, we can simplify the second term. When we raise a power to another power, we multiply the exponents. So we have 0.5 to the power of 3 times x minus 4, which equals 0.5 to the power of 3x minus 12. Now we have two terms with the same base 0.5. When we multiply powers with the same base, we add the exponents. So we have 0.5 to the power of x minus 4 plus 3x minus 12. Let's combine like terms in the exponent. We have x plus 3x, which is 4x, and negative 4 plus negative 12, which is negative 16. So our exponent becomes 4x minus 16. Since the bases are the same on both sides of the equation, the exponents must be equal. This is a fundamental property of exponential equations. So we can write 4x minus 16 equals 4. Now we can solve this linear equation for x. First, let's add 16 to both sides. Next, we divide both sides by 4 to isolate x. Finally, we get x equals 5, which is our answer. Here are some important tips to remember when working with exponents. Tip: when multiplying powers with the same base, add the exponents. Tip: if powers with the same base are equal, their exponents are equal. Reminder: when raising a power to a power, multiply the exponents. Warning: adding powers with the same base is not the same as adding exponents. We need to solve the equation 2 raised to the power of x plus 1 minus 2 raised to the power of 6 minus x equals 8. The first step is to rewrite the equation using the laws of exponents. we can rewrite 2 to the power of x plus 1 as 2 to the power of x times 2 to the power of 1. And similarly, 2 to the power of 6 minus x can be rewritten as 2 to the power of 6 times 2 to the power of negative x. For our next step, we'll multiply both sides of the equation by 2 to the power of x divided by 2. This smart substitution will help us eliminate the negative exponent and simplify our equation. Let's simplify what we've got. When we multiply 2 to the x by 2 to the x, we get 2 to the power of 2x. And when we multiply 2 to the power of 6 by 2 to the power of negative x by 2 to the power of x, we end up with 2 to the power of 5. Let's calculate 2 to the power of 5, which equals 32. So our equation becomes 2 to the power of 2x minus 32 equals 4 times 2 to the power of x. To make the equation more manageable, let's substitute a for 2 to the power of x. Then 2 to the power of 2x becomes a squared. And 4 times 2 to the power of x becomes 4 times a. So our equation transforms to a squared minus 32 equals 4a. Now we can rearrange to get a standard form quadratic equation. We have a squared minus 4a minus 32 equals 0. Let's factor this quadratic equation. We need to find two numbers that multiply to give negative 32 and add up to negative 4. Those numbers are positive 4 and negative 8. So our equation can be written as a plus 4 times a minus 8 equals 0. Now we can solve by setting each factor equal to 0. So either a plus 4 equals 0, which gives us a equals negative 4, or a minus 8 equals 0, which gives us a equals 8. Since a equals 2 to the power of x, we have 2 to the power of x equals negative 4 from the first case. But this is impossible since powers of 2 are always positive. So this case gives us no solution. From the second case, we have 2 to the power of x equals 8. We can rewrite 8 as 2 to the power of 3. So we have 2 to the power of x equals 2 to the power of 3, which means x equals 3. Therefore, the solution to our original equation is x equals 3. Let's remember some important exponent rules that we use to solve this problem. One key rule is that when multiplying powers with the same base, we add the exponents. So a raised to the power of m times a raised to the power of n equals a raised to the power of m plus n. Another critical rule is that if two powers with the same base are equal, then their exponents must be equal. So if a to the power of m equals a to the power of n, then m equals n. Welcome to today's lesson on solving exponential equations. Let's solve the following exponential equation using the properties of exponents. To solve this exponential equation, we'll first rewrite the expression by using the properties of exponents. For the first term, 2 to the power of x plus 1 can be written as 2 to the power of x times 2 to the power of 1. And for the second term, 2 to the power of 2 minus x can be written as 2 squared times 2 to the power of negative x. Next, let's divide both sides of the equation by 2 and multiply by 2 to the power of x. This gives us 2 to the power of x divided by 2 times the expression 2 times 2 to the power of x plus 4 times 2 to the power of negative x equals 2 to the power of x divided by 2 times 6. Now, simplifying the left side of the equation, 2 times 2 to the x gives us 2 to the power of 1 plus x, which is 2 to the power of 2x. And the second term simplifies to 2. So we have 2 to the power of 2x plus 2 equals 3 times 2 to the x. To make this equation easier to work with, let's substitute a for 2 to the power of x. With our substitution, we can rewrite the equation as a squared plus 2 equals 3 times a. Rearranging to get a quadratic equation in standard form, we have a squared minus 3a plus 2 equals 0. We can factor this quadratic equation. A squared minus 3a plus 2 can be factored as a minus 1 times a minus 2 equals 0. Now, we can solve this equation by setting each factor equal to 0. Case 1, when a minus 1 equals 0, a equals 1. Since a equals 2 to the power of x, we have 2 to the x equals 1, which means 2 to the x equals 2 to the power of 0. Therefore, x equals 0. Case 2, when a minus 2 equals 0, a equals 2. So 2 to the x equals 2, which means 2 to the x equals 2 to the power of 1. Therefore, x equals 1. So the solutions to our original equation are x equals 0 or x equals 1. Let's summarize what we've learned. Today, we solved an exponential equation by expressing all terms with the same base and applying exponent rules. The key steps were: first, convert all terms to powers of 2. Second, combine exponents using the product rule. Third, set up a quadratic equation and solve for the variable. Our example was 2 to the power of x plus 1 plus 2 to the power of 2 minus x equals 6, which gave us solutions x equals 0 and x equals 1. For further practice, try solving equations with different bases or negative exponents. In today's video, we'll solve an exponential equation step by step. Let's look at our example. To solve this equation, we'll first convert all numbers to powers of 3. We know that 9 equals 3 squared, 27 equals 3 cubed, and 81 equals 3 to the 4th power. Now, we can use the exponent rule that states when we multiply powers with the same base, we add the exponents. So, 3 squared times 3 cubed times 3 to the 4th power equals 3 to the power of 2 plus 3 plus 4, which gives us 3 to the 9th power. Continuing with the same rule, we multiply 3 to the 9th power times 3 to the power of 2x, which gives us 3 to the power of 9 plus 2x, or 3 to the power of 2x plus 9. Now we have 3 times 3 to the power of 2x plus 9, minus 3 to the power of 2x plus 9. We can factor out 3 to the power of 2x plus 9 to get 3 minus 1 times 3 to the power of 2x plus 9. Simplifying 3 minus 1 gives us 2. So we have 2 times 3 to the power of 2x plus 9 equals 2 times 3 to the power of 19. We can divide both sides by 2, which gives us 3 to the power of 2x plus 9 equals 3 to the power of 19. When two powers with the same base are equal, their exponents must be equal. This gives us the equation 2x plus 9 equals 19. Let's solve for x by subtracting 9 from both sides. This gives us 2x equals 19 minus 9. Simplifying the right side, we get 2x equals 10. Finally, we divide both sides by 2 to find x. So x equals 5, which is our answer. We have the equation 5 raised to the power of 2x minus 6 equals 1. We start by recognizing that any non-zero number to the power of 0 is 1, so we can write 1 as 5 raised to the power of 0. Since the bases are the same, we can set the exponents equal to each other. Now, we solve for x by isolating it. First, we add 6 to both sides. Next, divide both sides by 2. And finally, simplify to find the value of x. Let's verify our answer by substituting x equals 3 back into the original equation. 5 raised to the power of 2 times 3 minus 6, which is 5 raised to the power of 6 minus 6, which equals 5 raised to the power of 0, which equals 1. So our answer, x equals 3, is correct. Now, let's move on to our second example. For our second example, we have the equation 2 raised to the power of x minus 1 equals 5 raised to the power of 2x minus 2. We start by expressing the right side with a common exponent. Notice that 2x minus 2 can be rewritten as 2 times x minus 1. Now we can rewrite this using the power rule. 5 raised to the power of 2 times x minus 1 is equal to 5 squared raised to the power of x minus 1, which equals 25 raised to the power of x minus 1. Here we have an important observation. No power of 2 equals a power of 25, except when both exponents are 0. So we set x minus 1 equal to 0 and solve for x. Let's verify this solution by checking if 2 raised to the power of 0 equals 25 raised to the power of 0. 2 raised to the power of 0 is 1, and 25 raised to the power of 0 is also 1, so 1 equals 1, which is true. Therefore, our answer is x equals 1. Let's summarize the key rule we used in these examples. When solving exponential equations, if the bases are the same, we can set the exponents equal to each other. If the bases are different, we need to either convert them to the same base or identify special cases where the equation holds, such as when the exponents are 0. In this lesson, we solved exponential equations by expressing both sides with the same base and equating exponents, and by recognizing when exponents must be 0 for equality to hold. Remember, for equations of the form a raised to the power of m equals a raised to the power of n, set m equal to n. For equations with different bases, like 2 raised to the power of x equals 5 raised to the power of y, check if the exponents can be 0 to yield equality, or try to convert to a common base. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.